Hi, and welcome to the lecture When Things Go Wrong, Dealing with Errors in Our Python Program. We're always going to get errors because that's just part of, programming. And that's totally cool. We can deal with them. We just, have to stay calm, stay relaxed, deal with the errors. So in this lecture, we have four main objectives. We're going to figure out try, except finally, which is a way to handle errors. We're going to recognize some common errors that we can run into. Then we're going to learn how to read our error messages to identify where the error occurred. And through all of that, we'll figure out how try, except finally changes the top to bottom evaluation of code. Because remember, almost all of this is about how it changes the top to bottom evaluation of code. All right, so here's the problem. Consider this code over here. We have age, input age, and then it tries to turn it into an integer, okay? So what happens if somebody enters ABC? Maybe you've tried this in your own program, and what happens is the int function can't handle ABC. That's not a number. So it does something which it raises a value error. And we end up getting this weird thing here, trace back, file, blah, 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 value error, invalid literal for int, with base 10 ABC. So you can see we typed in ABC and the integer function, the int function, which is like, I can't do that, gave us this message here, invalid literal for int ABC. And that's a value error, that the value that we gave it, ABC, is an error. And when that happens, our program crashes. So the solution to this is to use another pair of keywords in Python, try, except, and we try some code, and if something bad happens and we get an error, we handle the exception, we handle the error. So here we're going to try, and it's indented. Remember, it's indented because there's a colon here. That means we can have indented lines. The indented line here belongs to the try. So anything that's indented under the try is part of the try. So we're going to try this line of code. So it'll run input age. If we type in ABC like this, integer will look at that and be like, I don't know what to do with that. And it raises a value error. So we don't even get to the assignment part. It just says, I have a value error. And so because it has a value error, it tells that to the try block, and then the try goes and finds the except block that has value error for it. And in this case, because we typed in ABC, it'll print out that's not a number. And then it just continues on. So with this in place, we're handling our error here. We're handling that exception, and the program doesn't crash. This altogether is called structured exception handling. Structured exception handling, otherwise known as SEH. And the reason why is because this is kind of weird. It's not that we have structure in our code, it's that our exceptions have structures to them. Value error is a special kind of structure, which we'll learn about in a couple of modules from now, called classes. So value error is an object of the value error class. Value error is the value error class. And that's the structure we're talking about. And exception handling is being able to say, oh, int raises a value error, so we can handle it with this except block. The try and the except, I just said this, but let's look at a program now. And so age is equal to -1. And what we're going to do is we're going to get somebody's age, okay? So while age is less than 0, which it is because we start off with -1, this while loop, all of the indented lines here are owned by it, and it's going to loop. So we get to this line here, and it's like, try the next lines, okay? Try whatever lines you've got. And here somebody tries to enter an age, and they enter ABC. What's important here, as I mentioned beforehand, when ABC gets sent to the integer, the assignment doesn't even happen. And because it doesn't happen, age is still equal to -1. So it's going to boop out here to this value error exception. It's going to print out age must be greater than or equal to 0. And then it's going to go back up here to the while loop. And because age didn't get updated, because age wasn't updated, age is still -1. So age is still less than 0. So it's going to do this again. Give me your age. We'll get an input from it. Maybe they actually pass in 3 this time. Integer can turn that into a 3. And so now age is equal to 3. No exception occurred. Nothing bad happened. So we skip over all of the except blocks. We skip over all of them to the next line. And the next line is, let's go back up here to the while loop. And now age is equal to 3, and 3 is not less than 0. So while says, I am done looping. And then it goes on to the next line of the program. What's really important to understand here is that integer, when it throws that value error, it doesn't even run this part. Okay, so age stays the same. It stays -1. And then we end up printing and looping. All of this stuff here is owned by the while block. This is a try. If it succeeds, if there are no errors, it just ignores the exception blocks and just continues. If an exception does occur, something bad happened, the try block will look at the except blocks, and you can have multiple except blocks here. You could have an except, syntax error, which would be really weird, but okay, syntax error like that, and some lines of code there. If through a syntax error, try would look at this and be like, nope, not value error. How about this one? Oh yeah, syntax error. I'll run that one. So you can have multiple except blocks for a try, for a single try. One try can have multiple except blocks, okay? That's important to understand. So now let's take a look at some built-in errors that Python gives to us so we know what it is that we can use in our except blocks. We can try something, and then we can handle those errors, okay? So let's take a look at the ones that we can run into most often. First up is the attribute error. We're going to start running into this pretty soon. So let's say I set name equal to Curtis. Now, name is a string object, and the string object has a function on it, a method called upper. So if I print name.upper, it prints that string in uppercase. If I print name.something that does not exist, then I get an attribute error. And that tells me string object has no attribute, does not exist. So this thing here, whatever I typed, that doesn't exist. Normally what happens, you'll see this in your program, if you accidentally type something like, what if I typed name.ooper like this? It just fat fingered a misspelling. Once it got here, it would throw an attribute error and say, I don't know what ooper is. It would say attribute UPER. So that's an attribute error. Indentation errors occur when you are trying to run your program. If for some reason you were like, and then you indented print, and then on the next line you accidentally indented the line even more, you can't do this because this thing here doesn't have a colon. It doesn't expect more indented lines. All of this should be indented at the same level for that if statement. And when that happens and you try to run your program, it'll say indentation error, unexpected indent, and then it prints the line right here that was indented incorrectly. In our book, we've imported math and we've imported random, which gives us functions that'll do like math functions and create random integers and random numbers. So if you import math, you can then use something like math.pow, for example, which calculates exponents. But if you import something that it doesn't know about, goo goo, then you end up with a module not found error, no module named goo goo. So you would need to go either change this name to something that's real, or you install a package named goo goo. And we'll find out how to install packages much later in our class. But this is module not found error when you try to import something Python doesn't know about. The name error occurs when you try to use a variable that doesn't exist. So here we're creating a function named print name, and it prints name, but there's no variable. You see that? But Python will go ahead and do that. It'll create a function for you because maybe later there's a global variable named name, and it can print that global variable. So while Python is creating this function, while it takes this code and puts it inside that variable, no error occurs. But when we call that function, print name, what it's going to do is it's going to come up here and it's going to go to that first line of code and it's going to be like print name. And Python's going to be like, what name? There's no variable named name. So then you end up name error. The name of the variable name, which is this right here, is not defined. So that's when you use a variable that you haven't yet created. Name error. Syntax errors occur when you try to run your program. So take a look at this program here. There's our def and our print name and our print name. Now it has a variable, it has a parameter, so it can print it out. But we end up with a syntax error because it says expected colon right here at the end of def print name. Sure enough, I forgot this colon right here. And so Python tells me, oh, you missed something there, pal. And so I know that I have a syntax error because I forgot to do something that Python expected. Zero division error is pretty self-explanatory. It happens when you divide something by zero. So, for example, here's a program that's going to do some division for you. You enter the dividend and it turns it into an integer for dividend. You enter the divisor and it changes that into a divisor. But if you enter the number 0 here, then you end up with some number divided by 0, which will then be a zero division error. And it tells you division by 0. And later we'll find out how to find out exactly where that occurred because it's in this part, this ... part. We'll look at how to read these exceptions, the ... part, because it's kind of cool. So this is the zero division error. So that traceback part that I was just talking about, that ... part, let's look and see how we read the errors traceback. And it coincides with call stacks. So make sure you've watched the functions lecture part 3 to understand how call stacks work, okay? Because it's important. So here's some code here. We have the if dunder name equals main, that calls main. And then dividend calls get integer, which returns this get integer. And then divisor calls get integer and it returns get integer, and that gets stored in divisor. And then we call this divide method and pass in those two values. And all it does is return the division of those two. Not much of a method. But if somebody enters 0 here, and that gets turned into 0 for the divisor, then that value 0 gets passed here, and that's the value that gets sent into the variable named bottom. So when we do top divided by bottom, we end up with a 0 divide by 0 error here, a zero division error here. So let's look and see over here in this traceback how we got to that. So I entered 10, I entered 0. Now it says in the file traceback.py, we start at line 17. So we came here and line 17 is the first function we called. Then we're in file traceback line number 13 inside main. We're inside that main function. It called this line on line 13 right here. Let me erase some of this crap because, I erased too much of it. Anyway, so we were inside main, right? So module, at the module level, we called main on line 17 right here. Now on line 13 inside of main, on this one here, we called this divide function. And then we're in another area of the call stack in traceback.py on line 3. We're inside the divide function here, which is line 3 of our file. And it shows us here is where the division occurred, right here. So we can trace through our call stack how we got to that line, or if all we're interested in is where is the problem, we look at the last entry here, the one right above what kind of error is, and it tells us line 3 right here, that's where your error occurred. Like that. So we can end up with more than one kind of error with this. Let's take a look at code and run it and take a look at those different types of errors that we get back. So here's that code again. I'm just going to go ahead and run it. Boop. And now it's running and it's going to ask me for this dividend. So right now, where are we? We've gotten down, it created the divide function, it created the getInt function, it created the main function. It checked this and said, good. We're now inside main. And right now we're on this line, which said dividend, getInt, enter dividend, which means we're inside this function right now. And we're on this prompt, right? So enter dividend is the variable we passed in, or is the value we passed in for the prompt variable, the parameter variable. And that's what's being run with this input right now, enter dividend. So if I enter something that integer can't handle, let's say I enter ABC and hit enter, let's take a look at this traceback here. So starting at the top right here, here's the traceback. It says line 16, you were in the module and you called main. So that was right here. I was in line 16 and I called main at the module. Then in the main function on line 10, you called getInteger. So here on line 10, I called getInteger. And inside getInteger on line 6, I called intInputPrompt. So now I'm here on line 6. And it says invalid literal for int ABC. So this is where the error occurred when I typed in ABC. And what happened was I got a value error here because int was like, I don't know how to handle that. And that value error went to here and it said, can you do anything with this? Is there a try block? No. And so then it went to here and it said, can you do anything? Is there a try block? No. And then it went outside to the module and it's like, crash. Okay. So let me run it again. Oops, let me delete this and run it again so that it doesn't have all that crap. So now I'll enter a valid dividend and now, oh, I have this incorrect. This is the bad program. Hold on just a moment. I need to fix it's, just me. This should read enter divisor like that. Ha! Looks like I never ran this program before. So let's get to this enter dividend. I'll enter 10 and now I'll enter ABC. What happens? Well, I get the same sort of error because it's the same kind of error. It's a value error for int with ABC. And that happens on line 6 in getInt. You can see that right there. So if all I'm interested in is fixing this, I need to go to line 6 and fix it. So here I have that return int prompt thing. Well, I can do some, I can do some really cool stuff here. I can do while true. So I'm just going to keep looping and then I'm going to try, okay? And then I'm going to accept that value error like this. Print not a valid number. So what about variables? What about all that kind of stuff? Remember, if this ends up raising an error right here, none of this even happens. So no return is going to happen. So if int fails and it throws this error for value error, it's going to go to this except block and start running this. Then once it's done with that block, it's going to go to the next line. And the next line is like, I don't have anything. So I'm going to come back up here to the while loop. And then it's going to run the try block again. And so it'll try this part again. And then if it succeeds, if this part here succeeds, then no error will be thrown and the return statement will just return the value. So this is a nice little concise way to do like value, input validation, value validation. So now that I've got this set up, let's try running it again and see if we get that error. Enter dividend, ABC, not a valid number. Enter dividend, ABC, not a valid number. 10, enter divisor. Do you see what happened? It skipped because I entered a good number here. So let's actually step through it. I'm going to put a breakpoint here. And then I'm going to run it and it should stop here after it gets to the first int. So I'm going to go ahead and run this with my Python debugger. And we can see here in the call stack, I started off in module down here in main. Then I got to this dividend, this get int right here. And now I'm inside get int on this while true. So the first time through, I'm going to step over to this try block. And the try block says, I'm going to try the lines inside me. So here's the try. Return int input. So the first thing it's going to do is it's going to call input prompt. Okay, so that's the first thing it's going to do. Boop. So enter dividend. And now I enter ABC. What happens? Enter. This integer blew up. That function blew up. It's like, I can't handle ABC. So instead of returning the value, it just said, I ignore this. That can't happen because I need to go handle an error. And once I have that, now I'm at this error block, value error. And so it's going to print this, next line, print not a valid number. It prints that out. And then because it's at the end of the except block, it goes out and goes the next line. There is no next line. So it comes up here back to the true. Okay. So now I'm back at that true block and I'm going to go through this again. So I step over. The try block says, okay, I'm going to try my stuff. It's going to run this input here. Boom. I'll enter my dividend 10. And now you can see it hopped out. Now it's down here. Down here, this get int, if we look at the variables over here, there's this return value get int right here, which was returned, and then that value got assigned to dividend. So now it's inside dividend here. And now we'll end up calling get int again with that whole same sort of thing. And so it will check to make sure that everything is good. So I'm going to keep running this program here. Let's continue. So now we're at enter divisor right here. Enter divisor is the prompt we've passed in right there. So now we're at this while true again. I'm going to get rid of this breakpoint and just play it. Enter divisor, ABC. An exception was thrown. So now we get print not a valid number. It comes back to while true. It tries this block again. It runs the input prompt part. I enter 20 like that. And then int returns the value 20, or int returns the value 20. Our function then returns that 20. That gets assigned to divisor. We do the quotient, we print the quotient, 10 divided by 20. So let's run this again. And this time we'll do 10 divided by 0. Now we get another error. So if we just want to fix it, all we do is look at this last line here, 0 division error. So we had to divide by 0 because I entered 0. And then right here it says line 2 in the divide function. This is the line that caused the error. So let's go look at line 2. Right here, we have this return top over bottom. Well, bottom is 0. So what do we do here? So maybe we do something like try that. And what happens if we get, a 0 by division error? 0 by, come on. Oh, Video Studio Code is not my friend. Okay, what happens if we get this? What do we want to return? Let's return error. Let's just return that string. So divide, in this case, is either going to return the actual number, top divided by bottom, or it's going to return the error string, and then that will be put into this quotient, and then we print it out. So let's try running that. I'm going to get rid of those highlights. And so now enter dividend 10, enter divisor 0, error. Great, what happens if I run it again? Enter dividend 10, enter divisor 5, and I get 2.0. So this is how we use our try except blocks to be able to handle the errors. And we try to put our try and except on the line, just for that line that will actually have that error. So in summary, we learned how to use try and except. We add a finally onto the block to do whatever happens, whether or not there is an exception or not. You can read about that in the book. Recognize common errors. We saw a whole bunch of those. How to read the error messages and identify where the error occurred. I cannot stress, this was the most important part of this lesson right here, which is how to read those tracebacks, how to read the exception messages, and how they refer to the call stack. and how they, each entry in the traceback right here is a entry in the call stack. And then finally, we learned how try and except changes the top to bottom evaluation of code. Try tries some lines of code. If an exception occurs, it jumps to the except block that matches that kind of error. And if it doesn't exist, it just keeps going. Finally, always runs. You can read about that in the book.